Okay, hi student. So we will continue chapter 1 Redox Equilibrium Chemistry Form 5 still 1.1. Okay, still subtopic 1.1. Psalm 46 verse 10. Be still and know that I am with you. So what will you learn? This is oxidation and reduction part 2. Okay, this is part 2. Okay, so the objectives is to explain redox reaction based on the change in oxidation number and to investigate the displacement reaction as a redox reaction. So previous knowledge, you already know what redox is, kan? So redox itu adalah where oxidation and reduction occur simultaneously in one reaction. Okay, determinations of oxidation number. What is oxidation number? The oxidation number or oxidation state is the charge of the element, okay, in a compound if the transfer of electron occur in an atom to form a chemical bonds with other atom. Okay, so ingat oxidation number itu dia punya charge lah. Okay, dia punya charge. For example, positive 2, positive 3, negative 1. Okay. The oxidation number of an element in an ion or a compound can be determined based on the following guidelines. Okay, the first one, you should remember this. The oxidation number for all element is 0. Setiap unsur, kita tahu kan, unsur yang neutral, tiada charge lah kan. So, semua ini adalah kosong. Dia punya oxidation number. Second one, the oxidation number for a monoatomic ion is equal to the charge of the ion. For example, this one, copper 2 ion Cu2 plus. So, oxidation number dia 2 plus. Potassium ion K plus, so oxidation number dia positive 1. Bromide ion Br negative, so oxidation number dia negative 1. Sama dengan charge dia. Oxide negative 2, aluminium positive 3. Okay, aluminium ion Al3+, dia punya oxidation number sama macam dia punya charge, iaitu positive 3 lah. Okay. Number 3, the oxidation number of the element in its compound for group 1, group 2 and group 13 in periodic table are positive 1, positive 2 and positive 3 respectively. Okay. Group 1, positive 1. Group 2, positive 2. Group 13, group 13, positive 3 lah. For example, lithium chloride, LiCl. Group 1 dia, Li, positive 1. Sodium oxide, Na2O, Na dia, positive 1. And then magnesium oxide, MgO. The Mg is positive 2. Aluminium chloride, the Al here is positive 3. Number 4. The sum of oxidation number of the element in a compound is 0. Okay. Maksudnya di sini ialah the sum of oxidation number for sodium chloride NaCl is 0. Sebab Na is positive 1. Cl is negative 1. So positive 1 plus negative 1 becomes 0. Okay. Dalam sebatian, jumlah oxidation number dia adalah 0. Example, sulfur trioxide SO3. Sulfur trioxide SO3. Determine the oxidation number of sulfur in sulfur trioxide. Sulfur trioxide is SO3. We want to find the oxidation number of sulfur only, the S only. Okay, the S only. So, yang kita perlu tambah adalah S itu X lah. We don't know, right? We don't know. So, plus, we have 3 oxygen, 3. And then, oxide, kita tahu charge dia adalah negative 2. Right? So, here, 3 times negative 2 is negative 6. right? Negative 6. So x minus 6 equal to 0. So x is equal to positive 6. X is equal to positive 6 lah. So oxidation number of sulfur in sulfur trioxide SO3 is positive 6. The fifth one, the sum of oxidation number of the element in polyatomic ion is equal to the charge of the ion. Okay, contoh. The sum of oxidation number of ammonium ion NH4 plus is equal to the charge of the ion, iaitu positive 1 plus di sini. Maksudnya charge hasil tambah charge bagi N dengan H4 adalah sama dengan charge keseluruhan NH4 ammonium ion, iaitu positive 1. Okay, example, the oxidation number of N is negative 3. Oxidation number of 4 hydrogen positive 1. We times with 4. 4 times 1, 4. So 4 plus negative 3 become positive 1. 4 plus negative 3 become positive 1. So the total charge of this one, NH4 plus, is equal to the charge of the ion, ammonium ion, NH4 plus. For example here, determine the oxidation number of carbon in carbonate ion, CO3 2 minus. We want to find the oxidation number of carbon only in this carbonate ion. So remember, the total oxidation number of carbonate ion is equal to negative 2, the charge itself. So carbon here we don't know, so we write as X plus. We have 3 oxygen, so 3, 3. Oxide kita tahu charge dia negative 2. Negative 2 equal to, here, the charge, negative 2. So here X is equal to negative 6. X negative 6 equal to negative 2. So negative 6 pindah di sebelah, jadi positive. Positive 6 minus 2 become positive 4. So the oxidation number of carbon is positive 4. Okay. Seterusnya, the oxidation number of hydrogen in a compound. The oxidation number of hydrogen in a compound is normally positive 1. Betul kan? Hydrogen itu oxidation number dia biasanya positive 1. Tetapi ada pengecualian dia, iaitu in metal hydrides. Dia punya oxidation number adalah negative 1. Become negative lah. Example lah. The oxidation number of hydrogen in hydrogen chloride is H, kita tulis sebagai X, plus Cl kita tahu dia punya charge negative 1. So X tolak 1 sama dengan 0. So X is equal to positive 1. Betul kan? Oxidation number of H is positive 1. Ini yang kebiasaan berlaku. Tetapi yang di sini, determine the oxidation number of hydrogen in sodium hydride. Okay, hydrides. Dia punya oxidation number akan bertukar jadi negatif. So here, sodium hydride. So sodium is positive 1. We know sodium is positive 1. Plus X, the hydrogen, X is equal to 0. The total charge here is 0 lah. 0. So here X is equal to negative 1. So the oxidation number of H in metal hydrides, okay, example sodium hydride, is negative 1. Okay, ada dia punya pengecualian. Number 7. The oxidation number of oxygen in a compound is normally negative 2. Betul kan? Oxygen charge dia negative 2. Tetapi ada pengecualian juga, iaitu in peroxides. Dia punya oxidation number will become negative 1. So we look at this example. In magnesium oxide, the O oxidation number is negative 2. Because Mg is positive 2 plus X for the oxide is equal to 0. So X is equal to negative 2, right? But in peroxide, H2O2, hydrogen peroxide. Okay, we determine the oxidation number of oxygen here. Hydrogen we have 2, so 2 times positive 1, the charge for hydrogen, plus we have 2 oxide, 2 times X, because we want to find the oxidation number of oxygen, is equal to 0. So here 2 pindah di sebelah jadi negative 2. So X here, negative 2 divide 2 become negative 1. So nampak kan oxidation number dia, oxide itu become negative 1. Ini adalah pengecualian di dalam peroxides. Okay, yang seterusnya, the oxidation number of elements in group 17 is normally negative 1. Betul kan? Macam fluorine, macam chlorine, kan? Okay, the oxidation number of fluorine is always negative 1. The oxidation number of chlorine, bromine, and iodine is usually negative 1, except when they are bound to a more electronegative element such as oxygen. Thus, the oxidation number will have a positive value. Okay, ingat fluorine memang sentiasa negatif 1. Tetapi oxidation number untuk chlorine, bromine, iodine biasanya negatif 1 kan, because diorang ni they are in group 17, so usually negative 1. Tetapi bila chlorine, bromine, iodine dia bound to element yang lebih electronegative, more electronegative element seperti oksigen, okay, so dia punya oxidation number akan bertukar menjadi positif. Okay, ini adalah dia punya pengecualian. Contoh, the oxidation number of fluorine in hydrogen fluoride, HF. So H we know positive 1 plus X for fluorine is equal to 0. So X is equal to negative 1. So oxidation number of fluorine is always negative 1. Second example, the oxidation number of chlorine in potassium chlorate 1, KClO. Potassium, we know potassium is positive 1. The chlorine, we want to find the oxidation number, so we put as X. The oxide, we know it is negative 2. So total charge, or total oxidation number is 0. So 1 plus negative 2 become negative 1. So X, negative 1 pindah sebelah jadi positive 1. So nampak kan? Dia akan bertukar menjadi positive value. Sebab the chlorine bind to another element yang more electronegative. Oxygen is a more electronegative element. So dia punya oxidation number will change into positive instead of negative. Okay, we try for bromine. Oxidation number of bromine in bromate 5 ion, BrO3 negative. So bromine we don't know, so we put X plus this one is 3. Oxide is negative 2. This one equal to negative 1. Negative 1 ini kita ambil dari sini, charge keseluruhan ion tu So equal to negative 1. So here is negative 6. Pindah sebelah jadi positive 6. Minus 1 jadi positive 5. So oxidation number of bromine dia jadi positive 5. Alright? Understand Okay. You try this one. Determine the oxidation number for the underlying element. Show all workings, if any. Memang ada. So show all workings. MnO4 negative. Okay, ingat. Buat macam yang kita buat tadi. Alright. So try this one. You try this one. You can screenshot this video and you can try this one, this activity. You determine the oxidation number of the underlying element. Like number 1, This one is manganate ion. You find the oxidation number of this Mn only, manganese ion only. And this one is only for the Ba, barium only. And this one is only for the hydrogen. This one is for bromine. This one is for the copper. This one is for carbon. And this one is for sulfur. Vanadium. Try. Okay. Okay, next one is the oxidation number and naming of compound according to the IUPAC nomenclature. What is IUPAC? International Union Pure Applied Chemistry. So maksudnya penamaan dia adalah standard lah, IUPAC. International Union Pure Applied Chemistry, IUPAC. Transition elements are metals that normally exhibit more than one oxidation number in their compound. Okay. According to the IUPAC nomenclature, penamaan IUPAC, Roman numerals are used to indicate the oxidation number of the metals in their compound. Okay. For example, iron. Okay, iron, this one is FeNO3 2. This one is FeNO3 3. Beza dia adalah 2 and 3. This one is iron 2 plus. This one is iron 3 plus. Okay, here the oxidation number of the iron is positive 2. Here the oxidation number of Fe is positive 3. So dia punya penamaan ialah kita guna Roman numeral. Iron 2 nitrate. The 2 here adalah refer to the charge positive 2. The iron 3 nitrate here, the 3 here refer to the dia punya oxidation number lah, positive 3. Alright, so the Roman numeral indicates the oxidation number. So this is the naming of compound containing metals that have more than one oxidation number according to the IUPAC nomenclature. Okay, so this is the formula. The formula is here, compound formula is like this, MnO2. The oxidation number of the manganese is positive 4. So dia punya nama adalah manganese 4 oxide. So ada Roman numerals di sini sebab dia refer to dia punya oxidation number. So KMnO4. Here the oxidation number of manganese here is positive 7. So nama dia ialah potassium manganate 7. Sebab dia punya oxidation number 7. So here the oxidation number of chromium here is positive 3. So kita panggil dia chromium 3 chloride. K2Cr2O7. The oxidation number of chromium here is positive 6. So kita panggil potassium dichromate 6. Okay, so penamaan dia adalah refer to dia punya oxidation number. Okay, try this one. Try this activity. State the name of the following compound according to the IUPAC nomenclature. Copper oxide. This one is copper 2 oxide. Macam tu. But because this one Cu2O. The O is negative 2. So ada 2 di sini. So the Cu is 1 here. So charge dia adalah Cu plus. This one, the O is negative 2. The Cu is also positive 2. So copper 2 oxide. Okay, like that. Okay, next one. Conversions of iron to ion, Fe2 plus, to iron 3 ion, Fe3 plus, and vice versa. Compound of iron 2 ion and compound of iron 3 ion widely used in our lives. Okay, for example here, ini adalah ubat iron pills, iron pills iron untuk anemia kan, especially in pregnant women. Okay, the presence of iron 2 ion and iron 3 ion can be verified by using sodium hydroxide solution NaOH, aqueous ammonia NH3, the potassium hexacyanurate 2, potassium hexacyanurate 3, or potassium thiocyanate KSCN solution. Okay, ini kita sudah belajar dalam salt form 4. So conversions of Fe2 plus to Fe3 plus or Fe3 plus to Fe2 plus. Okay, this figure shows that the change in the oxidation number in the redox reaction is associated with the transfer of electron. Okay, so here the oxidation number of iron increases from positive 2 to positive 3. Betul kan? Because the iron 2 Fe2 plus, they release an electron. So they produce iron 3 ion Fe3 plus. Okay? So this is oxidation reaction. So maksudnya, the conversions of Fe2 plus become Fe3 plus. Itu adalah oxidation. Okay, now the conversions of Fe3 plus to Fe2 plus is a reduction reaction. Why? Why? Because the oxidation number dia sudah decrease from Fe3 plus become Fe2 plus, and also this Fe3 plus accept an electron to produce Fe2 plus ion. Okay, so the conversions of this one to this one or this one to this one involve oxidation and reduction. Okay, so next one is displacement reaction. Okay, displacement reactions of metal from its salt solution. Displacements of metal is carried out by adding a metal into a salt solution of another metal. A more electropositive metal is able to displace a less electropositive metal from its solution. Okay. Contohnya di sini. In this tube, kita ada copper 2 nitrate solution, CuNO3 2. Warna dia, initial color dia adalah biru. Okay, and then what happened next is we add zinc. We add zinc metal here into the solutions of copper 2 nitrate. Okay, so what is the observation? The blue color of the copper 2 nitrate becomes paler. Okay, becomes paler. Inference dia ialah the concentrations of Cu2 plus decreases. Dia warna biru sebab itu ion Cu2 plus. Tetapi oleh kerana dia tambah zinc di sini, concentrations of Cu2 plus ion dia berkurang, maka berwarna warna biru dia itu becomes paler. Itu first observation. Second is the brown solid. Brown solid is deposited. Dia akan nampak brown solid termendak di sini. Inference dia ialah solid copper Cu is formed. Copper ion Cu2 plus receive 2 electrons and forms copper atom. So sebab itu dia warna brown solid, iaitu the copper become solid sebab dia receive electron, 2 electron. So here the copper ion is being reduced because dia receive electron. The third observation is the zinc plate become thinner, menipis. Kenapa? Because the zinc atom ionize. Ionize maksudnya dia release electron to form ion, Zn2+. So dia release 2 electron to form zinc ion Zn2+. So di sini bila dia release electron, the zinc is oxidized ataupun undergo oxidation. Right? Okay? So maksudnya di sini displacement reaction telah berlaku. Okay, apakah itu displacement? Okay, penggantian, displacement. Contohnya, apabila pada permulaannya, initially, semua mata kamu melihat teacher. Semua mata kamu melihat teacher. Tiba-tiba, datang seorang gadis Korea. Dan apa yang terjadi ialah semua mata kamu memandang gadis Korea tersebut. Maksudnya di situ displacement telah berlaku. Maksudnya gadis Korea tersebut able to displace me from your eyes. Begitu. Okay? So, dia punya syarat dia ialah more electropositive metal able to displace less electropositive metal. Maksudnya, orang Korea yang lebih cantik itu able to displace less cantik. Yang less cantik one. Faham? Itu syarat dia. More electropositive metal able to displace less electropositive metal. Masih ingatkan apa itu electropositive? Electropositive itu adalah the tendency to donate electron. So metal yang lebih electropositive iaitu yang lebih cenderung untuk donate electron, able to displace the metal that is less electropositive. So in this example, the zinc is more electropositive compared to copper. Zinc is more electropositive compared to copper. So that's why the zinc can displace the copper from the copper to nitrate solution. From its solution lah. Okay? Sebab mula-mula di dalam solution ini mengandungi copper to nitrate. Iaitu Cu2 plus dengan nitrate NO3 minus. Tapi oleh kerana si zinc masuk di sini, zinc itu ionize. Ionize maksudnya dia release 2 electron. So sebab itu dia menipis. Bila dia release 2 electron, the zinc become ion. So when the zinc become ion, dia masuk into the solution. Okay? So the electron yang zinc release tadi itu, yang 2 itu, will be received by the copper. Copper ion yang dalam solution itu. Cu2 plus itu, dia receive 2 electron from the zinc. So, bila dia receive electron, the copper will become solid. So, sebab itu, kita akan nampak brown solid deposited here. So, copper ion berkurang sebab dia terima elektron daripada zinc dan dia keluar menjadi solid. So, the concentrations of the copper to ion will decrease. So, the blue color of the copper to nitrate solution will become paler. So, di sini kesimpulan dia, zinc ini, dia displace copper from copper to nitrate solution. Why? Because zinc is more electropositive than copper. Okay? So, half equation. Oxidation. Siapa yang mengalami oxidation? Zinc lah. Because the zinc loses electron. Siapa yang mengalami reduction? Copper. Because copper dia receive electron. Okay, so this is the oxidation half equation. Zinc will release 2 electron, become zinc 2 plus ion. Whereas the copper 2 plus will receive the 2 electron, become copper. So dia jadi solid. So brown solid. So now the ionic equation is, ionic equation kita combine lah. Left and left, right and right. The electron kita mansu sahaja. So this is the ionic equation. So ionic equation is the overall ionic equation is the combinations of the half equation for oxidation and reduction. Manakala chemical equation ini adalah yang penuh. Yang penuh sudah. Zinc plus copper nitrate become zinc nitrate plus copper. So here, the copper is being displaced by zinc. Nampak? Mula-mula copper yang in dalam solution. Kan? Lepas itu zinc masuk dalam solution. Copper yang menjadi, yang keluar daripada solution become solid. So here, the copper is being displaced by the zinc. Okay? Faham? So remember, electropositivity is the tendency of atom to release electron to form cation ataupun positive ion. Right? Electrochemical series is a series of metal arrangement according to the standard electrode potential in order of most negative to most positive. More electropositive metal are stronger reducing agent because the value of the standard electrode potential is more negative. So atoms are easier to lose electron. So this one is electrochemical series. This one is metal ion, this one is metal. Metal ion is oxidizing agent lah sebab dia buang elektron, become ion kan. Manakala yang ini adalah reducing agent because dia akan receive the electron become metal atau solid. So menuruni electrochemical series ini, the strength of oxidizing agent will increase. Okay? Down the electrochemical series, the strength of oxidizing agent increase. This one is metal ion. Dia akan receive itu elektron. So dia akan mengalami reduction. So ini adalah oxidizing agent. Okay? And this one is metal. Dia reducing agent. So dia undergo oxidation. Dia yang akan buang itu elektron. Manakala menaiki kumpulan ini electrochemical series, the strength of reducing agent increases. So terbaliklah. Okay, terbalik. Down the electrochemical series, ini oxidizing agent dia strong. Strength dia increase. Ini naik the electrochemical series ini, the strength of the reducing agent will increases. Okay, more electropositive metals are located at the higher position in the electrochemical series. Okay, lebih electropositive iaitu yang greater tendency to donate or lose electron, dia berada di atas compared to bawah. Second one, the reaction takes place involves the transfer of electron from metal atom to metal ion. From metal atom to metal ion. Okay? Sebab metal atom dia yang akan buang itu elektron. The more electropositive the metal, the easier it is for the metal atom to release electron. Betul lah, dia punya tendency is greater to release electron. Metals at the top of the electrochemical series are stronger reducing agent. The lower the positions of the metal, the easier for the metal to receive electron. Alright. Metal ion that are located at the bottom of the electrochemical series are stronger oxidizing agent. So tengok saja anak panah inilah. Alright. Okay. Displacement reactions of halogen from its halide solution. Halogen is group 17. Okay, group 17. The atom of halogen has the tendency to receive electron, kan? Kita tahu group 17 itu lebih cenderung untuk menerima elektron. Halogen become more difficult to receive electron. Therefore, the strength of these halogens as oxidizing agent decreases. Conversely, it is easier for the halide ion to release their electron, and the strength of halide ion as reducing agent increases. So, kita tengok di sini. Okay, kita tengok di sini. Alright. Okay, di sini kita tahu bahawa halogen group 17 itu dia lebih elektronegatif kan? Dia lebih cenderung untuk receive elektron. Okay, menuruni kumpulan group 17 lah. Down group 17, halogen punya reactivity decreases. Betul kan? Sebab size dia membesar. Bila size dia membesar, dia jadi lebih susah untuk dia receive itu elektron. Okay. So, dia punya reactivity pun decreases lah. Okay. So, untuk displacements of halogen, okay, the halogen at the top of group 17 is more reactive. So, dia can displace the halogen at the bottom yang less reactive from its halide solution. Okay. Yang at the top more reactive can displace the halogen at the bottom yang less reactive. Okay, tengok di sini. Di sini kita ada potassium bromide solution KBr. We add chlorine water Cl2. So we have observation. The first one, the color of potassium bromide changes from colorless to brown. This one mula-mula colorless, dia change into brown. Inference dia ialah bromine is formed. Bromide ion here, bromide ion release electron to form bromine Br2. Bromine molecule Br2. Maksudnya, the bromide ion here, Br minus, is oxidized. Okay, oxidized sebab dia release electron. Second observation, the color of chlorine water changes from greenish yellow to colorless. Di sini mula-mula masuk ni dia punya warna adalah greenish yellow. Tapi bila dia sudah campur dalam solution ini, dia jadi colorless. Kenapa? Inference dia ialah chlorine molecule accept the electron from the bromide tadi to form chloride ion. Cl minus. So, chlorine is reduce. Maksudnya, reduce di sini dia accept the electron. Okay, so half equation dia di sini. Mula-mula dalam solution ini adalah KBr, potassium bromide. Charge dia ialah K plus, Br minus. Okay, Br minus. Apa yang terjadi ialah the bromide ion, dia buang elektron. 2 elektron, so dia menjadi bromine. So di sini dia release elektron, so dia mengalami oxidation. So sebab itulah kenapa warna dia daripada colorless dia menjadi apa? Brown. Kenapa? Sebab bromine telah dihasilkan. Bromine molecule telah dihasilkan. Okay. Kemudian reduction pula. Chlorine tadi, chlorine yang kita add di sini. Di sini chlorine kita add, warna dia greenish yellow. Kita add, we add, dia akan receive the electron yang released by the bromide. Okay. So bila dia accept the electron, dia mengalami reduction lah. Accept electron kan. So bila dia accept the electron, dia become chloride ion. Okay. Chloride ion. Cl minus. So sebab itu warna dia itu daripada greenish yellow, dia jadi apa? Dia jadi colorless. Okay. So ionic equation dia ialah kita gabungkan the half equation in oxidation and reduction. Kiri tambah kiri, kanan tambah kanan. Without the electron. Okay. So the chemical equation is the potassium bromide plus chlorine water tadi become bromine plus potassium chloride. So here from colorless to brown, here from greenish yellow to colorless. So di sini kesimpulan dia, siapakah yang displace siapa? Siapakah yang displace siapa? Okay. So di sini kita tengok bahawa so di sini ialah klorin yang lebih lebih reaktif. Dia yang displace the bromine ataupun bromide from its solution lah. Okay. Sebab yang lebih reaktif, dia yang boleh displace yang less reaktif. Alright. So this one is the halogen and this one is the halide ion. Okay, halogen dia ini from F2 sampai A2. So di sini from F minus sampai At minus lah. Okay, so di sini menaiki group 17 ini, up group 17 element, the strength of oxidizing agent increases. And here, down the group 17, the strength of reducing agent increases. Okay, the more reactive the halogen, the easier it is for the halogen to accept an electron. Macam tadilah. This one. Klorin itu lebih senang untuk accept electron berbanding bromine tadi. Halogen that are located at the top of group 17 are stronger oxidizing agent. In contrast, the lower the positions of the halide ion in group 17, the easier it is for the halide ion to release an electron. So macam tadi, ini bromide lebih senang untuk release electron compared to itu chloride. So sebab itu yang tadi, contoh tadi, bromide yang release electron dan chlorine yang accept electron. Halide ion that are located at the bottom of group 17 are the stronger reducing agent. Okay, so kamu pelan-pelan cuba untuk memahami dengan lebih dalam mengenai topik ini. Okay, mengenai oxidation, reduction, oxidizing agent, reducing agent. Okay, so try to master this topic. Okay, sebab jika tidak kamu akan bingung. Okay, kelas. Okay, so Psalm 46 verse 10. Be still and know that I am with you. So God always be with you, be with us in your study especially. Alright. So please do your assignment. Alright, thank you class.